So, yeah, Out and About with Phillip Francis. He's been on Space News, and yeah, see?
All right. Nice.
All right, so I'm going to go and drag that guy in here. And let's see if I can add him to call. Invite to group call. Boom. See what happens. I didn't even message him. Let's see what happened. Will the electrician's on, too?
You should message him. You should be, courteous.
I know, I'm an asshole.
You are. I'm glad you admit it, Lee. The admission is the first step to solving problems.
Welcome to the May 6th edition of The Electric View. I'm Neil Thompson. Today we have David, Buddy, Heather, Robert, and special guest Phillip Francis. We are going to tackle the subject of electric weather and how the electric circuitry in and around the Earth itself plays a large and often disregarded role in meteorology. Please like and subscribe below.
You left it open. I'm sorry. Hello, hey, Phillip. How you doing?
I think he made it.
Not so bad. I'm here.
Nice.
Hello.
Thanks for joining us today.
That's okay. Hold on, let me just set all my bits and pieces in. There we go. How is everyone? Okay.
Good.
Great.
Good. We have Neil, Heather, Buddy. I'm David, and thanks very much for joining us today.
I'm Robert.
Robert. I'm sorry, Robert.
You're so quiet over there.
Robert's the most important.
He is.
Oh, come on now.
So, Neil, would you like to take the direction of where to go here?
Well, actually, if you would for just a second, because I'm actually typing to Will right here, who's one of our viewers, and he's going to see me typing to him on the show, and I'm telling to him in the typing that I'm telling him that it's on the show. It's like going to be a Mobius loop that's going to blow his mind. So
nice.
So I'm just doing that for him because he's like our biggest viewer, and now he's going to hear me talking about him too.
The electrician.
Yes, there you go.
Hello.
See, I'll shout out to the homies. There we go. Oh, hilarious. Anyway, go ahead and yes. So this is Phil. I think everyone knows. I just spent a little bit of time mentioning who you were. So, and we're going to talk about electric weather because this was your baby, and you wrote a paper on it, if I'm not mistaken.
Well, I certainly wrote a document. Putting my ideas down. It was quite a few years ago now, probably about 15 when I actually put it all together. And it's basically my ideas of how it works, really. What would you like to know?
How did you first get interested in it? Like, what was the first inspiration to get the juice flowing to like dive into it?
Being British, obviously, I have a love of the weather, but I'm a horticulturalist as well, and I suppose there's a desire not to get soaked.
Right.
So it's a good idea to find out, how the weather works, and so I had a good understanding anyway. But when I come across the electric universe, it was just a case of seeing where I thought it was going wrong. Because obviously mainstream weather can't forecast between more than 3 to 5 days because they only use fluid dynamics in their modelling rather than magnetic dynamics, which they should be using.
Right.
And so the convergence lines is not different air pressures, different amounts of charge rubbing up against each other.
Uh-huh.
Up and down tablets. The way I see it is, if you look at the globe, I don't know if you can get the globe out there. If you go to Knoll School.
What's that?
Do you know Knoll School?
No, I'm not sure. I'm not sure what you're referring to.
Okay. I was going to say, shall I find it? Hold on a sec. Let me shrink you down and open up my browser. Go to the blog site. And there's a picture. There it is. And so let's just pick out the one I want, which is that one. And yeah, this gives a good idea. Can I?
Yes, you can.
If you send me a link, that'd be fine. Or
yeah, I'm just trying to think where do I send it on your?
Oh, there we go. Okay. There you go. Hi, I'll see you.
Well, if you're using a PC, it's a little plus there, and you hit the plus, and it says share screen.
There it is. Yeah, I was looking for that. So, take a picture, share files, share screens. There we go. Okay, start. Fantastic.
Boom!
So,
Here we go.
Yeah. So here we've got in the Antarctica.
Whoa!
We have this is the low pressure, and so the Earth has got generally a radiation, which is the high pressure. And that's the radiation it's giving up after getting from the previous amounts of charge. So what we have is we have the aurora sitting over the South Pole, and we have the main down currents coming off of the aurora.
Just like on Jupiter.
Right,
Yeah,
I was just about to say that.
exactly. All planets are the same. It comes in at the poles, but here we see it quite nicely because we've got a lovely continent in the middle. Up the north, though, because we've got a mixture of water and land, the down currents get very chopped up. And this is why we have a lot more severe weather up the north, because the pressure has to do with both. So we've got the returning current coming out through the highs. And if we look, that most of the actual movement of charge, movement of wind, because that's what wind is, it's moving charge, happens over the oceans. Because the oceans are salty conductive, so the returning currents will even still come out through the oceans as a spiral because it's fighting to get through the water. From the land, it's just coming up, but through the water, it has to fight to get through it. It's attractive because it is salty, but both the down currents and the up currents have to literally fight their way through the water.
See, we actually talk about this, whether or not, for example, we were talking with Edwin regarding the inside of the Earth. And,
Bruce Laybourne,
and
too.
Bruce, of course, yes, not to discount Bruce. But,
Right.
what I meant is that, we were referring to, because of the flatness of oceans, especially the Pacific being as big as it is, the current runs along the top if it can. It likes the barriers between, just like telluric currents, like the barriers between conductivity and low conductivity. But go on.
They're following Earth currents, which we can see here, and so this is the currents. This is a similar current that comes off of this landmass, which we know is the Gulf, and we have a similar current which comes off of here.
Wow.
And we also have similar currents which come off of Australia and off of the other land masses as well.
Love the equator. Like the whole, you can clearly see a band right across the equator.
Absolutely. And you see that this is not a band, it's actually lumps and bumps. You know, this is like the surface of the sun. This is little.
We were talking about that too, yeah.
This is little tiny individual convections. All going on coming off through the water.
And Bruce was even talking about this when he was referring to Hurricane Irma, because he was looking at geological magnetic anomalies under the crust, and he actually predicted that Hurricane Irma would make that hard right turn up towards Tampa Bay, where there was a bunch of lightning strikes going on at the time, and he would actually predicted it before Noah by like 2 days.
Yeah, no, once you actually see it, these things are easy to understand. I mean, this is what, over the years, it's a case of, okay, we've got an incoming flare, it's given us X amount of the storm. We know in 3 weeks' time that charge is going to get through the Earth, and that's going to be in the return current. And so we're going to get excess weather in about 3 weeks' time. So you can actually time these things as well. It is once you actually put the electromagnetic dynamic into it, makes it a lot simpler. It really does.
These currents, just to bring it back, these currents, obviously, as much as we're talking about water, electrically speaking, they must also be in the earth, which is the telluric current idea. Just seeing how they form, especially in water, an actual coherent current, especially in the Gulf Stream areas and so forth. I find that to be fascinating. Just because it almost belies an electromagnetic phenomenon. It requires it.
Yeah, absolutely. So we've got two arms. We've got two toruses. One it comes out of the equator and goes back into the pole. It comes out of the equator and goes back into the other pole. As two individual toruses.
Actually, I think it might go the opposite, actually, because you know what, that's a debate, but, depending on how the circuit works, like we were talking, does the circuit come down this way from the poles, go out along the equator, and of course we know that there are plasma bands above the equator that sort of link the 30th parallel to the other parallel, and what's all this really mean?
The two sides of the charge, because because it is two, it definitely get this interference pattern going on between the two.
Yes, and it definitely has to come out. I mean, the homopolar motor effect, assuming in any sense that it is playing out on the Earth, and the Van Allen belts seem to belie that it is, then clearly this is this has to be this is the outflow along that area, and it's but I've never seen it with this kind of detail. So,
can I ask a question?
You certainly can.
Rotate it, please, back around South America, so you can see the Atlantic Ocean.
Okay, hold on. Let's go back to it.
Now he wants you to control the world. Just it's so demanding.
On that same current map. It was
South America.
Okay, so it's going.
That's the end of the Amazon, isn't it?
Right, it's going inward toward the Amazon, and it's really spread. And there's
the situation, it gets very turbulent there. Certainly, it increases in charge.
Well,
it's pulling it in, but along the North American coastline, it's in other places. It seems to be pushing it out. So when you zoom out, it shows you the direction of the currents.
The individual currents are all over the place. I mean, they really are really tightly packed. The generally is sort of crashing into the coast.
Is this hot and cold currents? Is that what's going on here? Cold thermal?
The color is strength of currents.
The strength, okay.
The strength of the current. So over here in the Gulf of Mexico, if you just zoom out just a little bit, please, so we can see the whole sphere of it with the equator facing us flat, so we can see that just perfect. So the way that these currents are going in, they're going in to the Amazon. They're coming out of the Gulf of Mexico. Throughout the Pacific Ocean, you've got a much greener band. There's a lot more mixing. Like the energy is flowing more uniformly. I don't want to say uniformly because obviously, but it's more well blended, as opposed to this spot between Africa and South America where there's a lot of blank spots and all of the energy seems to be going into the Amazon there, and that seems to be really different from all the other places. That's why see how.
Why isn't it doing that on Africa right there? It's only going.
Landmass, the horn of the landmass might be insulating it, but would that be what's pushing it all into the Amazon, or is there an attractor?
Actually, I don't know.
Well, if you look at the right side, if you look at the right side of the continent, every time so far, it seems like there's more tumultuity on the right side of the continent than the left side of the continents, and it's right along the equatorial band.
The Earth is rotating; it's pulling it that way.
Actually, since this is just the speed of current, we're not actually seeing electric current. He's not. I mean, we have this is just the speed. Yeah, we can infer something by that.
It produces electric currents by speed
induced. Look at this wonderful. Look what you found. This is the aurora, but in the water. You can clearly see that. It's going right through that. It's like a jet stream.
Yes, and especially along the equator, because the way that it was reading, it was almost like a sentence written in cursive. And then I thought, what if that's the the river of the band across the sky, and that's how they were seeing it, and that's where we get all of these intricate shapes that they border things in.
Yeah, so
the Andrew pattern. Yeah.
Oh yeah, you're just suddenly. I'm going. Now I understand ancient Hebrew, but I'm obviously that's certainly not true. Oh yes, and of course that Arabic script there that they write on stuff that looks really cool. I think you might be onto something. I'll have to. I think someone talked about that.
It looks just like that. That's what I was thinking.
But anyway, we're not. That's not weather. But I want to talk about that more later.
That one was really great for that. The Pacific Ocean.
This is something inside of. This is the Cape Index, which is convective potential energy, and basically they see this as heat. But I actually see this as the charge. This is the returning charge. And this potential energy I actually see as charge within the Earth rather than just heat. So I very much see this when I'm looking at weather systems. I'll lay this in as well to see how much extra charge is coming up, and this will give me an idea of the intensification of storms.
Is there a lightning? Is there a lightning map? A map of the lightning strikes on this?
Well, the thing is, I'll do this all from my blog, which is this when it comes up, and basically all my weather links are down the left-hand side, and you'll find that there's rain. Rain. But we have got lightning for radar as well. So we've got all the links there. On my blog, which can give me instant access to what's going on in this. Obviously, you can go all over the world, Europe, Asia, America, and this gives you in real time exactly what's going on. We can see that southern Europe is really quite active, and certainly more active than it should be for this time of year.
Italy's going, ha, you suckers across the Alps.
That's right. They haven't really got much going on.
Can you possibly go to Michigan? I'm actually mushroom hunting right now, morel mushrooms, and I'm headed into a storm, so I want to see if there's any lightning.
You do know that I'm recording this, right?
Cool.
I'm just kidding.
It's part of that.
Help give it a live action.
That's where I'm going, guys.
I'll give you 2 days head start before the cops are coming,
Well, look, there's lots going on in West Virginia. We've got a bit of Indiana, a bit in Carolina.
Well, at least something now is going on in West Virginia. I never hear anything about that place. That's a joke.
You have to come to a grip for all this information. So.
Yeah, usually all those storms start off at the front of the New Madrid fault. They start working their way northeast.
Right. Well, that's about the state of the play for today.
Yeah, right around the Arkansas, Tennessee area.
So arguably, all of the storms have to do with topological invariance, right?
I say it's the up currents rubbing against the down currents. And so, like a short circuit. And also what I see, as I said, mentioned, wind is moving charge. It's charge trying to ground. It is, if we go back to the big picture.
So is it motion trying to become stillness? Motion trying to be still?
No, air pressure is a byproduct. It's not the driving force. Heat and air pressure are byproducts. What it is, that is a current trying to ground. So it's been attracted by the salt water, and it will be grounding in the sea underneath. But where it actually rubs up against an up current, you'll actually get like a short circuit. And if we go into the water, we'll see that where the actual join is, it's actually creating cloud and actual. So what we're doing is we're changing the actual H2O molecule. So in an initial stage, we've got clouds being formed, and they're like negatively charged. So we've got water vapor becoming cloud by losing electrons, and then they become the catalyst for more water to actually evaporate out from the gas state and turn it into the water state. And when you lose energy going to a lower state, you must have energy release, and that energy release and then add to the actual wind. So what the wind is actually moving charge. It's a combination of the down currents and the extra wind that gets produced with the water molecule changing from the higher state of gas to the lower state of water, or if it's a double shift down to hail, which is, you'll get even more wind because you're getting double release of energy.
Wow. That's actually very interesting. Obviously, that's, not necessarily I could see it's true on a large scale, but obviously we all have experienced the effect of a beach, and we understand that, the heat is rising more over land and it pulls air across a beach. Some of that, obviously, the convection idea is true, but you're saying on a smaller scale, on a major scale, it's clearly
weather.
Yeah.
The odd bit of beach wind is.
Yeah.
We're
talking massive currents,
large scale. Yeah.
Yeah. We're talking big scale.
Obviously, the jet stream's a big deal where I'm from and probably where you're from, because it's like a ring current around the planet underneath the aurora. It moves with the currents of the wind, and as such, we understand that that's a barrier separation in a way. But
yeah, we can follow that. If we go to the top of the atmosphere up at 10 HPA, we can see that it's actually, it's mainly all going on down there in the south.
Wow.
Around the, and it's not a lot going on north, but as we come down through it.
Well, that's obviously a large current down there. I just meant, every time I look at the weather, I see the jet stream is marked off, because, we know what it's going to be like when we see these dips rolling across Canada. They dip down, and then you're like, okay, that's a big cold front that's moving along.
Yeah, that's the state of it now. Once we get down to the lower into the atmosphere, it starts to pick up speed. And the charge, which is coming in one lump, is now diffused through the layers of the atmosphere, and we now have these multiple shears of down and up currents as they fight in between each other. And this is actually the state of the jet stream at the moment. It's really quite messed up.
Have you had the opportunity of going to Tent Rocks in New Mexico? You didn't go with me that time in 2016, but I got to go in 2017. And to back up your claims about electric, especially ionic winds, there was they have these hoodoos that basically look like conglomerate rock, and they say, oh yeah, this was carved by water, but clearly it's not, obviously. But they have a rock sitting on top, and then there's a sort of a pyramid, a cone underneath of it that's protected, and the rocks look like they've been etched by what I can only describe as electric winds. Mostly subsonic, but through some of the passageways you can see them have gone supersonic because they've cracked the walls with the force of the shockwaves. But as Andy would say, if I didn't mention that, he'd be all pissed. But seriously, as it's wonderful the amount of power you can get from that.
That's right. A boat, if you think of a boat on a lake and the wash it creates, it's not the water doing that, it's the energy going through the water. And that's the same with wind, is the energy going through the atmosphere is the moving charge.
Tornadoes and hurricanes being the quote-unquote the ultimate effect of that, I guess. But
well, a tornado is different. A hurricane is a big system.
Yes.
Whereas a tornado is like a little tiny system off of a convergence line. So it's still grounding charge, but a hurricane's doing it on the big scale, whereas a tornado is doing it on the little scale.
Yes.
It needs to get that charge down, but it's doing it from that convergence line rather than the whole system.
Yeah, I see the, hurricanes being like, I think Ben described them as earth spots, Ben Davidson did. And then they spin up from the equator and start going, they start following a similar pattern. So you can see that it's a connection between, more than likely between space and the ground, or space and the water, or at least a higher altitude.
Yeah, well, the thing is, our lows are literally connections between the ionosphere and the Earth. They're not connections between the Earth and the Sun. It's purely.
Did I say sun? I meant ionosphere. I'm sorry.
Yeah. Well, see, this is where I think Ben gets it slightly wrong, and he sees the lows as the up currents, which is they're not. They're down currents. And yeah, so I'm not sure that Earth spots are sunspots. So I'm not quite sure how sunspots work yet. Whether
that was just a comment. Sorry.
Yeah, I know, but this is what a lot of people think. But I'm not convinced by this. And
okay.
Yeah, I need to know what an actual sunspot is. Whether that's a connection between the sun's surface and its ionosphere, because our spots are certainly the connection between our ionosphere and the ground. So yeah, I'm going to say are actually the same. Yeah.
Well, okay, so fair enough. Fair enough. I mean, we're just going to lower.
Question.
No, you can't. I'm not letting you. I'm going to interrupt constantly. All right, fine.
So if you were to describe like the general, like the low pressure versus the high pressure, as far as it forming these kind of vortices, could you describe them like from an altitude standpoint, and then perhaps how it relates to like the ground charge?
Okay, well, this gives us our finest example of what's going on, because that shows you where the major input is, and you can literally run all the way through the atmosphere from that. That's how the charge is hitting the south of the planet, and then as it comes down through the atmosphere, it starts to break up into the individual loads. But it is coming from the one source. It says breaking up as it goes down through the layers of the atmosphere.
Wow.
And yeah, it is basically the one current.
Yeah.
And it's where the downs interrupt with the highs, which is the radiation of the Earth. That we get the weather systems, and so we get all the water dissolving in the atmosphere where the lows are actually interacting with the highs.
Right. So as it enters, it's really coherent, large scale, and then it breaks up into these smaller scale. Yeah.
Yes, it's slow scale, but then as you go down through the
very cool.
Yeah, it breaks up.
And then ultimately it breaks up into, it fractates into smaller scale and into lightning. And it disseminates its charge into lightning, right? Off of all of these vortical structures that are starting as higher dynamics moving down to lower dynamics.
Yeah. Well, you need charge niches to balance across the different layers. And if you can't ground, then you'll get lightning because it will just intensify to actually make that discharge. But we see out north how much it's more, because we are both sea and land, how much the charge literally breaks up, and it gives us a lot more weather basically, because the interruption patterns are not like in the south where it's really quite coherent, where it happens in that ring directly below the aurora, the southern aurora, whereas up here it is literally happening all over the place. And you can actually have a look at where the aurora is today, and there it is.
Mm-hmm.
And we see that it does actually follow the coastline, because this is why we get water spouts happening along the coast, because it's where the charge can hit the ground, because the ground is just below the surface of the water, but the surface of the water is salt water, and so charge likes to hit the ground where you get this water ground boundary. And,
I was going to say there is a tendency, as far as electrically speaking, it will run along the edge of discontinuity between 2 points.
Yeah, it does that even when it's scarring a planet. We see that.
Yes, exactly.
On the edge. Yeah.
Because I mean, that's number one. You can tell by the land all up there where that aurora is that it's just etched to shit. I mean, it is like just mangled, the landscapes up there. But fjords and so forth, Scandinavian countries have, you know what I'm talking about. But
kind of like that canyon wall in Three Fingers Canyon too.
Yes, you know what I'm talking about. So, but what I meant was that it will go in to the edges of this, because, and this is where obviously the idea that the ring of fire is not a giant subduction zone, that there's more to it than that, that these connections, places like, for example, Iceland is like extremely active. The world is splitting apart there if you ever get a chance to walk through it.
Well,
So.
Iceland is right under that ring.
Yep. And there's volcanoes you can't walk anywhere without hitting a volcano. You can see 3 of them from just Reykjavik, and and geysers everywhere. And then they talk about, this is very interesting. They talk about when I was on the tour. I was lucky enough to go on one of those tours, and they were going over a lava field, and they said, in the past, they could see, and this is how they describe it, they could see red sprites and blue elves dancing along the rocks. So they would basically seeing electric aurora going right across the lava fields in the past. That's what they described it. Same type of thing that's described in Scandinavia with regards to will-o-wisps and elves and sprites that they could find in the woods. This, of course, leads back to feng shui and ley lines and all this other stuff that might have been going on when the Earth was more active, we'll say, in the past.
Yeah, you can see the lines a lot more clearly.
That's, of course, an idea, but it's one that seems to fit the facts anyway.
And of course, we had the stone labradorite, which is that glassy stone, which is obviously found up in Canada. And the ancient people said that was the northern lights coming down and creating it. And obviously, that was massive discharges from the aurora to making this glassy type of rock, which is found up there.
Really?
Yeah.
That's odd that I didn't know that. I've heard of labradorite, but I didn't know. It's right north of me, actually, but yeah, just like, but it's so odd because of just like trying to figure out everything that's in Siberia. Northern Canada has giant kimberlite pipes that are basically where we mine diamonds, and it's just a tube, like a cone going into the ground, like a giant fulgurite. And there's 3 of them across the northern parts of Canada, and of course we have lots of places that are like a place in Ontario called Sudbury is it's all metal. It looks like the moon, like it's all gray and nothing grows there. It's parts of Newfoundland are upside down, like it's like a rocky outcropping, but it's all rusted. And someone said, "Why is that rusted?" And it goes, "Oh, that's a part of the ocean floor that was lifted up somehow," they said, and then dropped upside down on top of the land. So, yeah. So, of course, they don't know how. They just say somehow. But, it must have been a violent volcanic event to throw. I go, you're talking a 3-kilometer piece of land that was flung somewhere, it must have been very powerful volcano. Yeah.
That's a big uplift.
This is beautiful. I could watch this all day.
So what would be if you had a model of what's going on like the subterranean or suboceanic level, if you were able to measure that, or perhaps there are, what would be your read on that? Like on the opposite side of it.
I wouldn't really read much at all. It's it's. I don't know how it affects marine life, these different currents up and down. But it's the thing that obviously I find fascinating is the actual convergence lines. Because if this was obviously purely air pressure, this would all be mixing. But it's not distinctive boundaries where the charge won't go, where the wind won't go. This is wind movement. And so it is obviously electromagnetic in nature. That's the only thing which actually would stop charge flowing, is running up against other charge.
Well, yeah, it's going to go, just like water will always go downhill, charge will always find its way to neutralize. It wants to complete a circuit. And it's things like that long, dark snake that goes all the way to Northern Ireland or Northern Scotland there.
Yeah, that's a lack of wind.
Yes.
And it's where the everything goes to zero because it's changing direction, right?
But we were just talking about this on, for example, when we were talking about dolphins blowing rings. There's a coherence to the bubble. It knows where one side is versus the other. It seems to be somewhat of like the surface tension has an electrical property to it, a ring current, something like that. And now, of course, might not be true. I've never really, measured the voltage potential between those points, but I can envision something like that because there's a coherence across, like 1,000-kilometer length of air. That's not, you don't get that unless there is a connection between those points. There's a coherence, basically. It has to know there's more structure there than just wind, as you had implied. Well, you didn't imply it. You damn well said it. There.
Well, those ring currents exist on the outside of Birkeland currents as well as on the inside. They're chock full of ring currents. Actually, the entire straw of the current itself, the cylinder, is made up and composed of ring currents. So it's toroidal and helical, and the helical induction is wrapped around the toroidal field itself. When Donald Scott was drawing some images and explaining this to me, I had already drew some pictures of it, of these toroids. So my question is all of this based off of thermodynamics? Is this all based off of heat? And all of these currents have to do with the magnetosphere resisting separation always?
Heat is a byproduct. It's all about moving charge and the current, the down currents and the up currents to the Earth, to our ionosphere. Heat is purely a byproduct. It's a bit misnomer. I mean, it's all a gradient of temperature between 0 Kelvin upwards. To an ice cube, 1 degree above freezing is boiling hot, and it'll melt. So it's all a case of degrees as far as heat goes.
Well, obviously, we can't discount that. We can't discount.
It all comes. What I'm saying is, it all comes from the sun, and it's all heat that we're resisting from the sun, and that's what's ultimately creating all of these different effects here.
Not exactly, no.
We're kind of calling it as the heat. The heat is the effect.
Yeah, the heat is the effect.
Byproduct. I mean, if you sit in a car and you're going along in the sunshine, and the sun feels quite hot, if you feel the window it's coming through, it's actually cold, because the actual window, the glass is charging up and then letting the charge through to hit your skin. And the heat is the electricity hitting your skin. It's not the actual heat itself. It's coming through a cold surface. It's coming through cold glass. So it's the glass getting charged up and then letting the charge through, and the heat you feel is the charge hitting your skin, not the heat. Does that make sense?
Well, I know that there is electromagnetic radiation, and to deal with electromagnetic radiation, there's only really so many things you can do. You have to reflect it or absorb it. And obviously, the ground, with all the trees and everything else, and its color, will absorb, and of course, the atmosphere will refract certain colors and whatever. And we can't discount the fact that the Earth gets heat from the sun. I mean, this radiation is quite intense. It's bright.
You're saying it doesn't get hot.
Well, of course. But you're saying is that the currents, the electric currents themselves, also generate heat as they roll through and create these temperature gradients and so forth.
So the way I see it is they create the heat, and then the substance that's gone through holds the heat and can reflect it. It's the charge in the first place which creates the heat.
Well, there's no argument for that, since technically electromagnetic radiation is certainly carries charge. I mean, it seems to have an effect on the planet just charge-wise as it goes around the planet every day. So,
right.
Michael Clarage would probably tell you more. But
no, I'm looking forward to him again in chat.
Oh, is he going to be there with you in Bath?
Yeah, he's coming over. Oh, Michael's coming.
Oh, awesome. Awesome.
So I don't know why you're not. You know, the gang's going to be there. You're not going to be with us. I can't believe it.
Because I'm poor.
You pay the effort.
But hopefully this is not a extended thing. I have prospects for a great job right now, so I just have to finish my training.
No, I know. I'm just.
I would love to be there and go through what you guys get to show me, like what it is, here's England. This is the shit that we have to deal with, and I'll be like, your roads are so tiny. It's tiny, tiny roads. I'm just kidding.
Yeah, Richard and Ida will be there. For
yes.
Sure. So,
right.
They're part one of the groups of our veterans and Richard's very excited about going. So. But,
yeah, I love that he.
It's really exciting, really, really insightful illustration of things here. It got my mind spinning on things. It's nice. Thank you.
Yes.
Yeah, it's all good. We all chuck our ideas and things out there and our observations, and I think we're rocking and molding, man.
Yeah. So like this is like live data basically we're looking at. Can you describe like the the people?
I think it is. I think it's every 3 hours it updates, something like that. Yeah. So it only gives a little amount of forward movement, but we can go up to 24 hours, so you can see how storms shift.
Okay.
But it doesn't go past 24 hours though.
Right.
Ah, okay.
And then, what are you doing? Any is there anything that's really like on the direct line of what you're researching right now that's exciting you?
No, really. I suppose because it excited me when I was trying to figure it all out. But having sort of been there for 3 years, it's just a case of watching it and see how well it works. Really, the model works. And, I don't have any problems with it at all, really. Because you can tell when things are, you just look at the solar storms and, you can tell when things are going to get, a bit more juicy when the solar storm hits and 3 weeks after when you get the return column.
Right. The thing that strikes me that it's just as far as like visualizations and stuff, it's you have the ability to move to different altitudes.
Yeah.
It'd be really interesting to see like them layered on each other. I mean, I know it would tend to get confusing a little bit.
No, this is what I'm thinking, because you've got to remember this. It shows it as a flat layer. The actual charge is moving down or moving up. Whereas it shows it's like going around in a disc in a flat pancake, and of course it's not. It's coming down or going up. So what you last saw was it's come from here as more of a circular motion. As it's come down, it's flattened out into the charge.
Yeah.
Not going all the way around. So you have to try and see it in layers.
Mm-hmm.
This is actually the exact same problem they have with the sun. Michael Clarage talked about that. I can't believe we're bringing him up again, but he talked about this with, and this will be a good conversation for you, he was talking about form follows function, and that you look at the layer of the sun and it looks like, it's just, nothing's going on. It's just more homogeneous. It's just the top layer of this. And then you go one layer higher and it looks like it's on fire. Like there's just stuff coming out of it. And you go up here and then of course you start seeing the loops and so on and more and more structure depending on the layer you're at. And it's the same thing here, obviously.
One thing I like about Sapphire is, it shows them layers of atmosphere around Sapphire. And that's a very good, sort of visualization of what atmospheric layers are like. And the charge has to literally go from one layer to the next.
And we see the same thing with clouds. I mean, we know that it's there. We know they have flat bottoms. No, I mean, I love this that we've sitting there going, we know how we made clouds. Clouds are easy. And then someone goes, why do they have flat bottoms? And you're like,
It's the layers. Yeah, that's right, exactly. That's why they do flatten out. And the reason the clouds are in the sky is because they're negatively charged by the Earth, and fog is positively charged and created by highs. And that's why that hugs the Earth and clouds don't, because they are negatively charged.
Well, I was going to say, but besides the fact of the charge, but it's like, in a way, clouds are storage devices of the light, using the likes principle that Gerald Pollack talks about, how you can have a bunch of positive and negative connections in a loose conglomeration, which of course is able to hold up 500 tons of water and such. But
this is it. I don't think it is holding up 500 tons of water.
Oh, you don't? Okay.
I think clouds are a catalyst for more H2O to change from gas to liquid. I don't think the clouds actually hold the water. I think they are just a negative catalyst.
They're the function. They're like the machine that the hydrogen and oxygen process through to produce the H2O.
They basically make the water change state, gas to liquid. I don't see clouds actually holding the water. I see it purely as a catalyst.
There's for the process itself.
See, well, yeah, I was just picturing it as a storage device, like layers on a capacitor, and you're trying to, because you have so much voltage at one point, so many voltage at the other, and just like on Sapphire, you have stages. Luckily, they're able to show that when it does that in a particular mode, because usually they're not visible in that layer in that form. Usually they're invisible, just like you're trying to discern it here. You're seeing a layer, and then you have to sort of discern the layer above it. What really impresses me is that how much, just like in astrophysics, this view of the Earth that you're looking at is obviously not taught in books.
Correct.
And just like in cosmology, all the good stuff that they've been finding in the last 30 years has been, since Hubble, for example, is such a shit show because they like it's really smacking at their theories, and they want the data, but they don't want to change their ideas, and it's like you have to be forced to.
It's all guesswork. It's all guesswork they go with. They call it theories, but it ain't theory, is it? It's guesswork. It's unproven guesswork. That's all it is. That's the way the mainstream science works. They guess, express that equation, express that guess with an equation, and then try and prove that guess right. And of course,
that's why they're all considered theoretical physicists, and they're theoretical, and we just all of a sudden the theoretical surpassed the actual factual empirical somehow, and just like
not somehow. They did it with a
power.
very good way, a very good trick. They used math as a proof. They said, well, this variable must be there, therefore. It's not, but math proofs only prove logical progression, but they don't prove cause and effect. And that divorce of cause-effect has caused such problems, I think. But
that's just a language.
Sorry, the bottom current like really caught my eye. Also, I was like, ooh.
I saw that too. Yeah, I was like, ooh.
See that? So here we go. Sorry, I didn't mean to change the subject, but I'm just like really like it's like the depth.
But you're gonna, aren't you?
I'm sorry.
It's okay. Go ahead.
There was so it's like the depth perception of the flat image that you're looking at. But there was see, that was cool. There was one that was like it looked like cloud layers, like it actually looked like a transparent sphere with clouds in it. Do you know which filter I'm talking about? Because it was amazing. It was at the very beginning. It was blue. They were like blue and gray. But it was there wasn't the currents.
Just about 20 seconds, 30 seconds ago, right?
No, it was at the very. It was like
at the very beginning. Oh, okay.
Yeah, like that. There was. Yeah, you could see the depth of where the clouds were actually sitting.
Yeah, that's the one with that's the water clouds.
There was another there. Is that it? It didn't have these currents flowing over the top of it, but I don't know. But it just I kept like everything. I wish I knew I had taken note of what it was called, because I kept like trying in my mind, like flipping all of the different, every time you flip the image, like flipping it back to that sort of an image to see, because it was like this might be closer to it. Yeah. The, like the telluric currents and the idea of a thunderstorm going on throughout the entirety of the sphere, not just in the atmosphere in the gaseous form above us, but also simultaneously happening within the Earth itself, right? Because like it's carrying
like dark mode, like dark mode telluric currents, and all these other different currents are that we can't really see until we have this type of view.
They weren't like that. They were big fluffy clouds, big clouds of charge, like he's saying, like this mechanism, right, that changes things into other things. It was like this cloud mechanism, so it had a current to it, yes, but also like a fluffy gradation that went through the solidness of the Earth, and like it's like a big plumy force that goes through it, as if it is like a thunderstorm. And so it's not necessarily this rush of water per se. Suddenly in my mind's eye, it turned into a cloud, like a storm cloud rolling through, like a thunder cloud just rushing through the whole entirety of the sphere. And maybe that's what it, I don't want to say what it actually looks like, but maybe that's what it
I mean, we'll be able to go back and look at it, obviously.
Yeah. So I'm sorry, I didn't mean to interrupt. I was really
great.
taken by that, and the way that around the other side of it, down on the bottom, when it was the multicolored one, you could see the vortex twist. Right? You could see the helical twist underneath another layer, and they were perpendicular to one another. Neil, you saw it.
I did.
Yeah.
But
that gives you.
It might be when it starts turning. You might have got distortion.
Possibly. Either way, one thing I learned just by looking at this, and this is I had this program. I think when Ben first showed the program on screen, I was like, oh, I got to look at that. So I remember grabbing that. I think it was 2015. But one of the things I noticed was how much land affects this. And it makes you question things like the Great Red Spot on Jupiter or the one on Neptune. Because if you see a constant location, that seems to indicate that there's a something charge-wise that's affecting
coherence.
Yeah, in that area. It's like
that's
stuck.
where my thoughts, Neil. That's exactly where my thoughts were. If I could just say something real quick, the dolphin blowing the bubble and moving it created the diocotron instability on top of the planets, a very similar type of loop current. So if you can envision those vortexes, the hexagon, the octagon, whatever size and point vortices they are, imagine the ring currents associated with those. If we could look at some of the planet's poles and see some motion of it, you can also see that they're persistent systems, and yeah, they're very structured, and there's a lot of coherence associated with them.
We can actually see that the aurora on other planets is visible, and amazingly enough, some of them were totally stunning. For example, on Saturn, we were blessed. I don't know if that's the correct word, to see to see what was called at the time the Dragon Storm, where there was a discharge. I know it sounds very strange, but two snake-like dragons with plasmoids wrapped, which they were wrapped around, were reaching up to the actual ring of the planet. So the ring system. So they get now that when we watched it through the cameras, they thought, oh, that's cool. And I didn't think much of it until I started thinking, what would it have been like standing there watching that happen while you were on the planet, if you could see that? And, you would see two giant red dragons reaching up to the sky, and it would be like it was on fire. It would have been very convincing. And it's those type of things. Yeah. Oh, I love that connection between those 2 points. I love that. You're just showing the bottom here and the other one there. I like that.
How many are there?
It looks beautiful.
5 going into 6.
Well, I think that some of this has to do with the notes that they play. The planets have a song, so to speak, the sound of the planets, and
everything has a song.
Thing so quickly.
Everything has a song.
Yeah, so we're going back to the red spot, and the fact you've got single places. Yeah, there's a lot of people now thinking that the point maybe where Venus comes from is actually below the red spot, and it's actually a mounting of rather large proportions, and maybe that's the point of where Venus erupted from.
It wouldn't surprise me.
But also, a thought that I have too is you see this one on the far up right. Wait, scroll back where you were because I was going to show something. Could you please scroll down just a little bit? But anyway, look, red spot has a trailing. It's got a trail like a comet. It's, you know what I mean. It's got a tail behind it, like loops following it. And on Saturn, there is a storm that happens annually that is an elongated storm that goes like along in a strip around it. And so sometimes what the spot is, damn it, I lost my thought because I was looking at these pictures that happens to me. But it's like,
who can argue though? I mean, they're beautiful.
Right.
But it's curious that some of them are round and some of them are elongated, like in this manner. There's something to that. See, like, 'cause it's banded, and then there's this big spot there, and then the one on Saturn propels itself through, but it's more just reminiscent of the trail behind the spot, and its fingers, how the fingers go down of this aurora. Like
the one on Saturn.
Yeah.
Well, yeah, many planets have different aurora that you can't even, like, just judging between them, the amount of power that just they're producing alone. I mean, we still see electrical etching on Io. That alone should be warning that it can happen on other planets. But, we're blessed here. Again, I use that word. I don't know why.
Because we are.
Because we are. Amen. There you go. Amen Ra. No, but we have an atmosphere, which protects us, unlike, Io, for example, that is just basically, without a magnetic field, it can impinge anywhere. We can only be impinged at on the poles unless there's an exceptional connection, like unless something, like a planet comes close and starts messing around with us, We're fairly protected.
I think that's down to the amount. That's why I call the outer planets plasma giants, not gas giants, because they are all electrically active.
Yes.
They are plasma, and this is what gives them the magnetic field. The one that I can see that with the Earth, so I think that's expanded in the past, and we've probably got a plasma core. But
it's not a bad argument, no.
Well, I think it's quite compelling when you actually look at the video.
And, I would be with you too. Don't worry.
Yeah. Yeah. So I think it's the amount of plasma. So which brings into question. I think it's Mercury that's got a magnetic field.
That's correct.
So you'd have to think, well, does that have a plasma interior? And also, what's the one in Saturn, the ice? Europa?
That's Jupiter and Europa.
Yeah, sorry, Jupiter. Yeah, and I think that's got a magnetic field.
Actually, I didn't know about that one. I do know, however, that planets like Neptune, we love the dynamo theory, but it's thrown away with Neptune, for example, because there is, if I'm not mistaken, it could be Uranus, but I think it's Neptune, that has an off-center field, and it's much closer to one pole than the other. And we've seen this type of effect with giant concretions on Earth, where it looks like a giant ball, but it's been cut or broken, and you can see that the core of that was closer to one side than the other. And Why did that happen? Why didn't it grow evenly if it was growing by, the conventional way? But electrically speaking, it would be passing through a material, and it would still be spherical, but it would attract more on one side than the other. And leaving I think that there's a hollow area in these, just like, I think gas giants and, all the planets, and probably including the sun, are all made in a similar way until nuclear fission or fusion starts messing around with them a bit. But they're all basically rocks, and obviously with larger plasma atmospheres. And they happen to have the mass, the discrepancy, I think, is, I'll go with Wall Thornhill on that it's probably has to do with an inverse of their charge. They appear lighter when they have higher charge, and this is why they are gas giants as opposed to as heavy as we are here. But that speculation, love the idea. I think I'm going to go with it right now. It's better than the liquid hydrogen metal idea, I don't think. But when I see this idea of an off-center that destroys the dynamo idea, and it sort of implies that plasma core idea that you were saying.
Yeah, well, I think the expanded Earth destroys the dynamo anyway, because obviously you just have this thing. If the Earth expanded 3 or 4 times the size it was, then obviously you're going to have something rattling around on the inside, which we don't have. So,
we do have, according to some people, we do have a hollow area where the core was, and then we have a liquid outer core. That's a really good interpretation of the seismic events, because we have the shadow zone and other things like that obviously indicate that there are layers of density inside the Earth.
I don't think there's layers until we get down to the plasma layer. But I'm not sure, or I don't know how shock waves would travel through charged plasma. So it has to be a highly charged one to create the Earth's magnetic field.
I think it's like a torus on the inside of the hollow cavity, and these cavities are eaten out because I've explained this before to someone. I think that you'd like these that all of the energy that you see on the outside of the planet, because of the fact that this is a reflection, just like the ionosphere has an internal ionosphere. There must be an internal ionosphere around the planet, otherwise the ionosphere would slam into the surface. So there's something keeping it out and away. But there must be different layers like that going down. And so that would imply then, because of inductance, that all the activity on the outside of the planet is also occurring on the inner surface, which would be a lot more powerful per square meter because there's a lot less surface area on the inside.
I think it's going straight through the Earth, reversing and coming out.
I wish it could.
That's what the effects of the auroras are, and that's why they glow, because that's the reversal coming out of the circuit completion, which is a concretion of Earth. If you think about the currents that are coming out of the sun, and the planets being forms of Markland convection, then whatever mainly the planet is composed of, then maybe those minerals, it takes that long to create the majority of those types of minerals to coalesce into the vacuum of space. So thus, that planet is composed of this because it's that far away mostly. This planet is more rocky because it's right in the Goldilocks zone, and the gaseous giants, if they were to be pulled closer towards the sun for some reason, they would become they would become stripped of all their atmosphere. Think of all that coherence with those geometrical patterns on it, forming it into concretion. Now, all of these planets are continually being filled with, arguably, all of those minerals aren't on the structure of the planet or the atmosphere or the internality of the planetoid, which means that a lot of it is streaming real time from the sun, allowing those particles to exist and persist in those different spatial arrangements, sort of like Markland convection from the center point source being the sun.
I wanted to correct something. It's not going through the planet straight from pole to pole. What happens is that you have current going in the north and south, and
how do you know? How do you know that it's not going through?
Well, let me explain. Okay, it's actually very simple, and I know exactly where you're getting your mistake. Basically, it starts going across the surface of the planet. I'm going to just say it's a magnetic sphere that's metal. I don't need to get into details of each planet. Yeah, let's go crazy here. Yeah. But if you notice in a Torella, you have, just like in this picture here, you have a ring around ring around the planet, right along the equator. Well, outside of that, there's a torus that's called the Van Allen belts, and that holds a different charge than the rest of the planet. And what this means is that this planet functions like what's called a Faraday disk, or a homopolar motor. And what happens is currents go in the poles of a homopolar motor, spiral as they go down, and then they go out along the equator. And while this is doing this, just like on the sun, likely it induces secondary currents and tertiary currents and other things like that. But the main current is going in the poles, out along the ecliptic. And this is how a galaxy works. And the reason,
a lot of energy.
Yes, it is.
Assume that it expels out of the equatorial plane.
However, it's a natural phenomenon. It's belied by the fact that, like the rings of Saturn or the rings of Jupiter, or where the moons tend to go to this neutral point, the magnetically neutral point along that area. This doesn't necessarily mean that it's not as efficient as a Faraday disk, because it's not a disk, it's a sphere. And it induces secondary currents, which are...
Is there a Faraday sphere? Maybe we should coin that and run with that.
Actually, it would be accurate to say it is a Faraday sphere naturally, but that's what a Torella would be technically. But you're dealing with a situation where this is one of the cool things about it is that, and I'm sure that you do, that if you take a battery and then you just put a magnet at the bottom and then you put a connection from point to point, it begins to spin naturally. It's the right-hand rule in effect, and it's very, number one, it's natural. It just naturally happens. It doesn't require an engine to make it work. And this effect is also what we use to measure power that's coming into our homes, because there is a direct relation to spin and current. So when you put this together, it allows for the planetary spin, it allows for the energy that's expressed, and it seems to have a circuit that we can see on the sun, and we can see it on the Earth. And it does appear to, just on Jupiter and Saturn and other planets, seems to be this effect. Now, to say that you have it all figured out, or that I have it all figured out, would be incorrect. But this would be this is a Donald Scott type thing. Like, it's very well established. This is more than likely what's going on. So it doesn't necessarily mean that there's not other currents, because we can see the induction. Look at it all. I mean, it's not evenly distributed. I mean, just as much as I would like to say, imagine a metal ball and just put it in space. Sure, that gives you the basic ideas. But when you get right down to it and start going through atmospheres and other things like that, it finds its own way and and obviously densities and air pressure and other things will change the flow, so to speak. Planets will do it too, like moons. Like, for example, you can see the footprints of the 4 major moons on the aurora of Jupiter. This seems to indicate that you can they can sense that through the magnetic field, which is pretty cool.
So I got a question.
I was just correcting. Go ahead.
Okay, according to the electric universe model, do the planets all form out of the sun as an accretion disk and into spheres, like form as rings and then spheres?
No.
Okay.
It's not required.
How do most planetoids form according to the electric universe paradigm?
Basically, if for anything like the gas giants, for example, Jupiter especially, according to myth, Jupiter was orbiting near where Mercury is. So it was an inner planet. Now, it was much like that because it was probably because of the alignment with the sun, the polar alignment, that it was likely ejected from the sun. So this was probably an incident where the sun got too much current early in its formation and had to get more surface area, and in so doing, electrically fissioned and barfed out a planet. Now that is not normal, so to speak, for moons. It seems that moons and other things like that were because of interactions between some of these gas giants and so forth. Because sometimes they'll create in a shotgun pattern. Basically, material will be pulled out and just go boom. As soon as the the magnetic field is no longer confining it, you have a shotgun of moons that will go flying, and like buckshot. Okay. But these are
okay. I'm really interested to hear some of Philip's commentary. Just he's here as a guest, so I'm curious a lot of his perspective here. Not to just cut you off, but
oh, that's fine.
To pass the buck here.
Yeah, well, this is. Yeah, I'm happy to listen at the moment. I'll interject. I think it's worth talking, saying.
It's a conversation.
Then ask away, but otherwise, I'm quite happy to sit and listen at the moment.
Oh, well, I'm not going to. I actually was pretty much done. You just asked about the formation of planets, and so there is the idea that when two bodies get close together, their plasmaspheres touch. They will pull material off of one planet and try to deposit on the other. In so doing, balls will be formed along that chain and shot out. And this is where you get many of the moons.
Okay.
In the interpretation of this, it's very rare to get the actual electrical fissioning because that really requires something to overcharge a surface to the point where it can no longer hold any more charge and must increase its surface area. This basically causes the inner part of a body to be ejected outwards through the surface and then piles up near it, and then of course is pinched into a sphere. The Earth is actually a wonderful example of what will likely be, and this is again just my interpretation. Not a lot of people have expressed this, but the Earth in the past, for example, under natural philosophy rules, was considered to be a conglomeration of different parts that were sort of stuck together. That sort of faded away with the idea of plate tectonics. But ignoring that and going back to the old way of looking at it, perhaps the Earth was a bunch of spheres that were shot out and then re-crunched together. So you have basically silicates coated with iron that are then crushed together and coated with silicates, and then, of course, expanded over time. And this appears to be what the Earth is. And this could be a reason why it expanded. And other planets don't tend to do that very often.
It seems like the Earth is something completely unique, really.
It's special, indeed.
The way it has, it has expanded, and it would be very hard to actually. I was thinking about this and looking for aliens and looking for other planets which could possibly have them. To find something which is unique like the Earth is not going to be easy, I don't think.
No, in the electric universe, it's more than just a Goldilocks. Number one, the Goldilocks zone doesn't matter as much.
Well, it's the Drake equation.
Right, but it doesn't
matter.
Well, not as much. Because the Earth has been shown, according to our history, from what we can understand, we have moved in our orbit. We used to be closer to where Venus is, and now we're where we're at now. But that, number one, that doesn't mean it's true, but it does mean that the Earth has some special properties that seem to be conducive to life, whether or not it has different conduits through it that allow life to be expressed in sort of bacteria getting kicked out of black smokers or whatever's causing this. But it also means that we were likely inside of a plasma sheath for a long period of time, just like that, like a small ball. And that's where life began to develop. And then now we're here. super. Well, it would have been awesome. I'm sure the idea of the purple dawn, the idea, even distribution in all directions. It would have been neat.
So I guess my main question is sort of like this: the sun. I see things as a persistent necessity. Like all of life on Earth is persistently necessitates off of the sunlight. So I see the sheaths around the sun, sort of like the heterodyning layers of plasma, the central source of a plasma. At each one of those heterodyning intervals, planetoids are formed, and the sun pushes off all these different elements, and they are accreted to certain intervals, and some of them can't accrete to certain intervals, like whatever Neptune is predominantly made of.
Who knows?
Whatever it is. Okay. Now that element it can't concrete here fully in the form that it wants to. So its most stable form is out there towards that planet. So the majority of that type of element is flung out and concreted towards that sphere. And each planet is constantly like this. Because
Jim may agree with you on that. Jim Winiger might agree with you on that. But from what I know, things are stabilized a bit differently. But I don't.
Right.
We can't be sure.
I can just interject.
Please interject.
Because I'm watching this was one of the Neil Adams images that you're showing right now. This was one of the first really kind of like mule kicks that I got where because as a kid I'm looking at a globe, you can see how they fit together just like he's showing here. Mm-hmm. And I'm interested in what your ideas are on that.
I actually,
I'm asking you.
Phil? You're not asking me. Please, ask Phil. Good idea. Okay.
I think it's the obvious planet has played in the past, and the idea of plate tectonics is although I admire Alfred Weng, who came up with it originally, because he very much went against the mainstream. But I'm afraid it was wrong. It is. I can see clearly we have an expanded Earth.
Well, let's not say wrong. Let's say that because Carey, I think his name is, or Casey, I can't remember. One of those
Neil?
Words.
Can you do me a favor?
What?
Just let the statement finish.
Sure. I'm just going to say it's not totally wrong. That's all.
That's all right. This is part of the game, by the way.
Yeah, let's just continue. All right.
Yeah, we're working on our style.
Well, it's a discussion. That's all right.
Yeah.
Yes. So I can't see anything else but the Earth expanding, which does means it underwent some massive changes in the past, which were, I don't think, were that long ago. The way I see the formation of the solar system generally, if we look at other star systems, we see that suns are on like strings of pearls, formed along a filament. So if we could say that the Jupiter, Saturn, Neptune and Uranus were actually outside the heliosphere, and then I would say that the Ice Age was possibly when we were dragged into it, and I think there's probably, we see that the entry of Neptune and Uranus was probably what was mistaken for what was called Nibiru, as a 3,600 year gap. So I'm sort of like looking at new timelines and trying to draw up new timelines which I will carry on with people at conference. And we are looking at very, very recent events when all this happened, rather than all the years in the past, which obviously conventional guesswork says so. Because we also have to look at work, I don't know if you know the work of Gentry, Robert Gentry, and the polonium halos.
Yeah, we were talking about those.
Oh, really?
Oh, yeah. Robert and I had a great big conversation while we're in the middle of a freaking desert about them.
Oh, brilliant. Yeah, because obviously they can only form within seconds before they break down into other elements. So, which really does show that we're talking about instant formations.
Or more or less instant, yeah.
Yeah. Well, yeah. Within minutes.
Within minutes, for sure.
Right.
And the only thing I can see rock cooling down that quickly, again, is coming back to charge and the fact that charge is the cause of temperature. So a change in charge would actually cause a change in temperature, not necessarily for the hot, but for the cold as well. So it's something, obviously, I don't have the resources to explore, which is a shame.
Well, if we could make electrified rock and then make it glue to something or weld to something, yeah, I mean, we'd have to have a lot of power to do that. But I was only going to say about, before I was rudely interrupted by my friend David.
This is like sanding, sanding a piece, a carving to a fine finish. That's all.
I'm going to call you names if you don't be quiet.
It's just a matter of running. We'll just, you run on.
No, I have a whole bunch of names, a bucket full right here. I was only going to say about.
I'm ready.
Okay, are you ready? You're ready. No,
Yeah,
I was only going to say about Casey that I only wanted to give him credit for noting the fact that this happened. He only had the Atlantic to play with. He didn't even see it in the Pacific. I'm not saying. I only meant that good on him to challenge the orthodoxy, who were adamant that he was wrong, and he died just not even having proved his thought. I mean, 20 years later, they went, "Oh crap, he was right," which I give him credit for getting to where we are now. But you're absolutely right; he was technically wrong because the Earth does appear to be expanding, but because of the Pacific. But
everything fits together when you shrink it.
Yes, exactly.
Yeah.
But to give you some dating, your taxa idea, taxa, basically plant and animal life on different continents, give a general time frame on some of these splits. If only we could date them more accurately, because obviously now we have problems with conventional dating with polonium halos and radioactivity not being constant and so forth. You were going to say something, buddy. I kept cutting you off. Sorry.
Yes. Looking at this map here, first I want to note a few observations that I've had. The last map was a little better with it was more polar circular and oriented, but so yeah, look at that. So when you think about the poles of the gaseous giants and how structured they are, it's almost like it takes that type of structure to that many cycles of that violent type of structure to start to create life inside of a spheroid or a planet. And if you look at our poles, it's like those that exactitude of structure inside of the vorticular the vorticity. Anyway, those particular shapes went into the earth and onto the like a Torella, and all of that electrical charge went into the plants, and then the plants emulated the field structure itself with the pentagon or pentadactyl or pentagram type of structure of flowers, because all flowers, all fruit are actually a product of flowers. They're flowers first. So the spot where the flower comes on the tree is also the same exact spot that produces the fruit. So
okay.
Then you can argue, or at least envision, that this type of hyperdimensional structure went into the Earth, and we used to have these type of if Earth might have been something like a gaseous giant before, or something like that, and it took a long time to become what we are now. It condensed so much to a point, and then it started expanding outward, and that kind of makes a lot of sense. And then after the structuralism is what it's called. After all of this, these designs moved towards the topology, the topological aspects of electrical charge turning into something. It emulated that, and that goes back to the emulation hypothesis. And
you're going into
clearly
and morphology, et cetera.
Yes, morphology and mycology.
Then as a reflection of as above, so below.
Yes.
We actually talked about that before, about Howard Littman, Pan-Orpheus there. He wanted to ask me specifically about what would happen if you were, I think we talked about this. What would happen if you were actually on Mars and you had to grow something there? What would happen to it? Would it grow like it did on Earth, or because it's in a different electric field and different vibrations, would it grow differently? And, this gets into, did electricity in the past change the way that things express? That's why we had giant creatures, or that type of thing. It's, again, a very interesting question.
It's always these balances of proportion. That's where it gets into the, instead of looking at absolute measurement, start thinking about proportion, ratio, and you start seeing like all these things pop out of it.
Yeah, it's completely a holomorphic matrix, and there's a clear pattern between the way that the filament or the path or the currents produce the structure, and that's the fields always producing the event. All of eternality is leading to this moment for us to have this conversation. Every single thing in eternity.
Just to compliment what you're saying, buddy. To compliment what you're saying, it seems like the currents themselves, although the time and the scale are directly proportional, the time duration. So, but they're scale independent. This action.
Yes. Yep. They are scale
as a function of time, the ratio of the scale over time.
Yep, that's exactly what Jake was saying. And so then you get into space-time fractals, and you can think about the Mandelbrot set, but the Mandelbrot set is just a type of it's not mapping the space-time coordinates. We need a system that maps the space-time coordinates, a vortical coordinate system. And the Doherty set is a vortical coordinate system. It's based off of vorticity. And it also incorporates, what's really clearly happening here is, I'm a map maker, and we're seeing that this map is fulfilling a lot of the electrodynamics in the systems of plasmoids and really fine structures and stellar formations. So it's mimicking and mirroring the as above, so below, and it's showing us that there is coherence between these larger scale systems and smaller scale systems, and it's not only showing you that there's coherence, it's showing you that there's the waves are embedded in it the entire way, the entire structure. It's because we harmonically have to embed with all other waves. That's another paradoxical thought. You're like, wow, how can all this happen at the same time and be so symbiotic? It's because of wave interference and wave destruction and constructive wave interference. But so my thoughts right now are all leading up to this moment. But my thoughts, my whole life were leading up to this moment. So it's the concrescence, and arguably all of this is just nothing but fields that are developing the form. there's a quote that I love by Jordan Peterson. Sorry, I just was privy to him. And he says, "The dream is the birthplace of the fully articulated idea." The dream is the birthplace of the fully articulated idea. It took a long time for that dream to be able to be crystallized into a fully articulated dream form manifestation for you. So not only are our dreams the birthplace of the fully articulated idea, but our forms are constantly the fully articulated idea. And so this goes from consciousness to materiality to eternality very quickly. And there's a scaling tensor. This is scale independent. What's great is our consciousness is not scale dependent. We can go off into any direction that we want. And that's really has to do with where your heart is. Your dreams are going to be led by your blood flow, the pump of iron inside of your body, which is formed from suns, as far as we know, iron.
It's a double vortex, not a pump.
Yeah, it's a total double vortex, and it's pulsating these rivers that don't have enough pressure to move through them. The vortices are even pressuring it. So it's the vortices inside of vortices inside of vortices inside of all living systems. And that's just, what's the word? Ventricle? Dendritical? When it comes to blood flow. But everything concretes to this type of pattern. This, it's a flow. If you study flows,
that's one of the things that we found last week really compelling, and I hope this blossoms up along with what Buddy's talking about. But and you're showing it in beautiful, just detail here. But it's being able to look at like things that we've seen before in a little bit of a different light and from a little bit different point of view. And she was taking sunspots and just doing just very slight manipulations of color on them and bringing out all this very interesting detail. And what I'm seeing with what you're showing here, just what would be like just really kind of illustrative of and perhaps like really nicely exploratory would be take what you have here and show and have the layers where you're, and I'm doing VR these days, but it's like be able to fly down into them and through them, and you could see the shapes that would be in dynamic movement, as in altitude, which would actually be a really cool project.
New project for you there, buddy.
Good project, yeah.
Both of you, actually.
So where do we get this data?
I can actually show you. I actually have this on my but I mean, he can link it as well. It's literally earth@nullschool.net. But there's a
it's great.
There's a I have it on my here. I'm going to link it just so you can, because I love it too. I as soon as I got it, I put it on my screen, right? So, but yeah,
Phil, I have to offer. I apologize. We go drifting in all kinds of directions here. So this is kind of the way we've been doing.
And they blame me. It's not my fault. I swear to God, I didn't do it this time.
Well, you're at the front. You're at the front of the line there. So
starts with Neil.
You're all a bunch of bastards.
It all comes right. It all flows down from Neil. So.
Yeah. That means on top of the poop pile. There we go.
Right. But thank you very much for joining us today. It was just a great presentation, and we'd like you to join us again if you could take the random meanderings that we do.
Oh, I absolutely love it. It's great to have a chat. Personally.
Nice. Oh, perfect.
Yeah, no. So you just got to give me a bit of notice, and I can always pop up on the Sunday.
That'd be great. Just awesome. A quick question, like you're bringing up Neil Adams. That really actually, I dove pretty heavily into those. It was like 2006 or so. What was your experience with that? And do you have any kind of particular anecdotes about what your experience was seeing that? And
Well, I've always been a bit of a rebel, seeing I'm an artist, so I'm never surprised with what I see, and I just sort of go, right, okay, that makes sense. I don't, because I left school quite early, and I taught myself basically everything I know. I'm not brainwashed.
Right. Indoctrinated into orthodoxy. Right?
No. So
I've had to break out of that egg. So.
Yeah, a lot of people have to, but luckily I never went into it in the first place. So.
Mm-hmm.
Didn't need
I'm a bit envious. So.
Right.
It's hard work doing it yourself though, because to actually get people to take you seriously,
right.
can be very hard at times. So, there you go.
Well, this is one of the reasons why we love this show, because people actually have something to say, and there's a way to say it that doesn't necessarily need to be so formal. I as much as I love, like we were talking about this before, there's presentations that are every word is known, everything is controlled, all the words are correct, because they really, really need to be that way because of who they're talking to, and their audience is, scientists and stuff like that, and they want to be taken seriously. But for a lot of people, yourself included, you want to be able to be understood, and you're not trying to speak to them because they're never going to change. It doesn't matter what you. I mean, look at. I mean, Piers Corbyn can be right 95% of the time, and they're still going to say he's nuts.
Right. Yeah, Piers is a great bloke as well. I've met him once.
Oh.
And, he's. I went to one of his talks. Also, where I've given a talk, North London Polytechnic Astronomical Society. And, so I went on to Piers' talk, and he's great fun. Good.
Well, and he has a point. And a lot of it has to do with this. If you don't know your theory, you're going to be so screwed. There should be no reason why we can't predict more than 5 days in advance. You
just got to use the right model.
Right, exactly. And this is the same thing we're having with cosmology and other planets. Like, you're sitting there going, wow, look at these forms. We didn't predict these to be here. I go, so you're trying to tell me that your theory is wrong? Oh, no, our theory's right. We're surprised. So your theory is wrong. No, you don't understand. We're right, but we were wrong. Oh, okay, that makes sense. That makes total freaking sense. And I'm baffled by that, because, I mean, when I see falsifications of a theory, just like this, I mean, you're seeing structure here all around the planet. You can see lightning on one side of the continent reverberate with lightning on the other side of a continent, and you can see it go back and forth in lightning strike points, and you're sitting there watching them, and you're like, these are 3,000 miles apart, and there's a coherence to it. Well, it's just wind and air pressure. Screw you, it is.
It's like hitting the sun and causing CMEs on the other side. It literally causes a shock wave, to the opposite point. Which
you're getting the idea, yeah. Like, I mean, and they didn't predict any of this
instantaneously, and that's the kicker, and that's the one there, because it doesn't. It sometimes even precedes it because of the bow shock, because of the shock, the wave before, with it pushing the charge out of the way.
Right.
So
that's connection. It won't be a bow shock. It won't be mechanical. It will be electromagnetic.
Well, yes, and we see the exact same thing with, I think it was one of those papers on radioactive decay, and they showed that if there's a CME on the sun, then the dark side of the Earth has radioactive decay slow down just before the CME goes off. And you're like, well, that's instant. That's a sensation. Like, our planet sensed that from over here, an astronomical unit away. Why? How? What is this? What causes radioactive decay? And you end up questioning. Just like this, what was that you said there, David, one time? You walked up and said, they say, ask me anything you want. And you just walked up and said, what is mass?
Yeah.
And their mind was just fried right there.
Right, exactly. That easy. Yeah.
With just one question, and they were like,
Well, after about a 20-minute, diatribe on I solved everything, and then that question just dumbfounded, and it's like, come on, it's foundational, obviously.
Well, I mean, of course, and this is where you make this is what makes everything go wrong.
The statement they were making was dependent on that,
and you don't even know what that is.
Yeah. You can't define it.
Well, I mean, we just talked about it earlier. Why do highly charged bodies seem to be lighter than other bodies? I mean, in space, why does a comet appear to be lighter? Why does the Saturn appear to float in water? Why does the sun appear to be made of hydrogen if it has a surface?
That goes back to changing matter states. When you put more energy into it, liquid goes to gas. Or matter to liquid. And so, and the higher states of matter are lighter. So I think it's quite obvious. You put more charge in, it will change matter state and get lighter.
We were, I think we'd even talked about what happens, that of course, following that line of reasoning, let's go into quote unquote the ancient past. And if heat can have an effect on matter, basically by changing the amount of heat in an object, you can change its physical properties. Because you can melt something, for example, or it could turn harder or more malleable depending. Well, what does higher charge do to materials? What does it do to biological materials? And this could lead into why it was easier for them not just to move stones or something, but to actually shape them. Or, why was, that kind of stuff. I mean, it's just speculation, but was metal harder? Was it,
were our thoughts more effective?
Well, there's a whole different ball game right there. Yeah.
Yeah. Were our thoughts more connected to, external, actualities? Like we could take, if everything's more charged, okay. What got me thinking about this is that there's a symmetry that all water goes through when it goes through phase transition. This symmetric structure, it's very beautiful. It has to go through that. So every time it's going through that, as it changes from phases and states, all matter has to go through some sort of intricate, beautiful symmetry phase transitions in order to, express its next state. And that's just a beautiful idea itself, I think.
Have you seen the one thing? I'm going to grab the screen just for a second here. One of the, because I'm watching that in the.
What, this is Dave? This is not Dave doing all this. This is Phil.
This is Phil. Yeah, it's Phil. Yeah.
Well, thank you very much, Phil, for doing all the pictures for this episode. It's very kind of you.
Absolutely. Yeah, no, it's great.
You're talking about stuff I know about.
I gotta get my chops down with this.
Yeah, you're much better than Dave. Can we have you on more? He's terrible at this.
I am. I know.
I'm just kidding. You're great.
You're right. I don't. Thank you. I appreciate it. No, I don't know, but I'm working on it.